A very good afternoon, everyone. Welcome, Rajendra sir.
Thank you, sir.
Okay, so the third session of the third day of ATAL FDP on electric vehicles will be on the topic of modeling and the simulation of on the drive cycle analysis, and this will be of
Hmm.
two sessions. First, we will start today, and then we have another session tomorrow in the second half again, same timing. So I would
Hmm.
like to introduce the Rajendra sir. Rajendra Kumar sir is associated with Professor Parvin Kumar sir at IIT Guwahati. Is presently working under him, and sir has done MTech at IIT Kanpur and BTech at University of Rajasthan, and sir has worked as assistant professor in Marwari Education Foundation groups of institution Rascot, and sir has also work experience of I think 2 years with the PM Dimensions Private Limited Gandhinagar project. I think at Chennai. Yeah. So thank you, sir, for joining us. I hand over to you for the session. Thank you, sir.
Uh, Thank you, sir. So, sir, are you, sir? I'm sharing my screen. Is it if it is visible to you?
Not yet. Yeah, it is coming.
Okay. 1 minute, sir.
Yeah, fine. Now it is coming.
Yeah, sir, may you see it?
Uh, yes, it is coming. Yeah, coming.
Yeah, synthesis of drive cycle.
1 second, sir. Yes. Now we got it.
Okay, sir. So, today I will be presenting this drive cycle synthesis technique that we used here in IIT Guwahati for making one drive cycle which meets the driving condition nearby this Guwahati or inside the Guwahati city. So, first thing, why is, this drive cycle synthesis or drive cycle is required, and the reason is that uh, when we design a motor, so for that motor, we should know uh, what is the load profile. And load profile means uh, what is the base torque, what is the base speed, what is the maximum torque, and what is the maximum speed required for the motor to run. So for a vehicle or for a motor uh, designed for vehicle application, uh, these operating conditions are not constant as they are in an industrial motor which is designed to run for a particular speed and particular torque. So hardly there is any large variation. Uh, but in a motor, it is not always possible that motor runs at a particular fixed speed and with a fixed torque. So it's we can say its operating point is not a fixed operating point. It has a wide range of operating uh, conditions, a wide range of speed and wide range of torque. So now, if we design a motor for a vehicle, the another concern is the weight of the motor and the size of the motor. So, for vehicle application, we need both to be very optimized. So motor should not be an oversized motor in terms of power and torque, or maybe, in other words, motor should not be an uh, oversized or overweight motor or overrated motor. And similarly, we don't need an underrated or underweight, underrated motor. So because that will be fail to drive the or propel the vehicle for the desired speed or the desired torque requirement. So if you may see the screen, uh, uh, here you may see these speed versus torque profiles for a motor or for a vehicle motor. So the blue one is the rated torque uh, profile, and the red one is the peak torque profile. So before we design the motor, these two characteristics should be handy. Means we should know these two characteristics of the motor. And how do we obtain these two characteristics? These two characteristics we obtain from this analysis of drive cycle.
Rajendra
And
sir, I
yes,
think we are not able to see the characteristic you are trying to show most probably.
okay, okay, just 1 minute. Sir. Sir, may you see now?
No, it is coming.
Okay.
Uh, yeah, yep.
Yeah, so these two means rated and peak torque characteristics of a motor. These two characteristics are required, and as we see for a grid motor, only one single dot or the single operating point in this torque versus speed plane is required. And here in this torque versus speed plane, we need the entire characteristics to be known before we go to design a motor. And these two characteristics are obtained from drive cycle analysis. And and in this slide, you may see that these seven requirements. These they should be known to us before we design a motor. And so here,
Ex- Sir, excuse me.
yeah, yes, sir.
Can you show it in full screen, sir? Please.
Okay, 1 minute.
F5, F5 in your system.
Okay, is it fine now? So from 1 to 4, you may say that these are the mechanical uh, parameters, and the rest two are the 5 and 6. They are electrical parameters. So these electrical parameters, they are constant. Means what voltage is available, what is the rating of intermediate DC to DC converter, and what type of battery we have, and how this battery connections are made. So, but these four parameters, 1 to 4, they are directly obtained from the drive cycle. And okay, so sir, is the screen visible? I have changed the slide, and
Yes, yes,
okay,
it is
so
visible, but you can maximize also, sir. You can make it full
mhm,
screen.
yeah.
Thank you.
So, how can we make us a drive cycle, or how to synthesize a drive cycle? So, what are there are many techniques are available in the literature, and these are the mostly or the popular techniques which are being used for drive cycle formation. The first one is microtrip based drive cycle. Second one is based on this Monte Carlo simulation, and third one uses this Marco chain process theory. Uh, the first one is very simple technique, and what is a micro trip? Micro trip means speed versus time profile from zero one stop to another stop. So at the two ends, the velocity is zero, and in between we have some velocity profile. So that is called one micro trip. So this the first technique uses only one micro trip, and using that micro trip, the drive cycle is made. And another techniques, they use a chain of data, a very large number of data, not a single micro tip. Uh, so many complete mm, uh, what we can say, the complete range of vehicles operation uh, data. So there may be many micro tips in between. So what is the development methodology? So here the first step is the route selection, and second route means the path or the road which we will be taking, whether it is inside the city or outside the city. And the second one is the data collection, and this data collection is just GPS data, velocity profile data. In the third step, we filter these collected data in step two, and then using that filtered data, we form a drive cycle. And once this drive cycle is made, we will evaluate its performance, and based on this performance, we select one or uh, 4 or 5 drive cycles. So these are the this is the complete path of this development methodology. And so step one of this path, that is the route selection. And route selection means the first one, we have to ensure that means we have to make sure that for which vehicle we need this drive cycle, whether it is a truck or a four wheeler or a light motor vehicle, uh, in four wheeler, or a bike or a sports bike, or a commercial bike, or any household purpose bike. So, and then what is the duty operation, and then road conditions, and for which road conditions we are making this or this motor or this vehicle. So that should be in match with the road conditions of this route, so that we can closely match these motor the requirements, uh, motor torque requirements. And then traffic condition and the geography also affects vehicles performance in hilly terrain. The stock requirement of the vehicle is quite different than the torque require wheel torque requirement in a plain areas. And why it is critical, as it has been already told that it will determine the motor size, and motor should not be overrated and underrated. So that we have to make sure while selecting a route. And then once the route is selected, we will pick our vehicle, and then we will run that vehicle in that on that route, and while running that vehicle, we will record the following data. And these data are vehicle speed, acceleration, and altitude. And altitude is required, especially when we design a vehicle for hilly terrain. And then the distance traveled, that will be automatically calculated. Or so now we need all these four data of a vehicle, and the tool we used here to record this data, that was the GPS speed graph plus, and any of its equivalent which gives the this data which this may be used. And number of riders uh, on the vehicle when we uh, collect this data, then the vehicle should be occupied in its full seating capacity, and that is two for a bike. So once we get these data here, you may see the two pictures are shown. The first one is the raw data, and second one, I'm sorry, this name for both the data is written as raw data. The one is the raw data, which is on this left side, and the right side is the filtered data. So, so why this data is required to be filtered? The reason is there are many unwanted spikes in the speed and acceleration data, and these spikes may be because of high frequency oscillations over this measured data, or data repetition, or they may be real. And so we do not need these spikes, and we have to remove them. And why we don't need these spikes? Because you may see uh, at very high speed, uh, at around this when time is around 60 second, and you may see some spikes at very high speed also. So what will happen? These spikes will increase the total torque requirement. Why? Because high speed, the torque requirement is already very high to overcome this windage friction torque, or the windage friction force on the vehicle's body. So already this torque requirement is very high at high speed, and these spikes will add increase uh, this the net torque term or net force term uh, because of this added acceleration to the vehicle. So here it will show an acceleration, and that acceleration will term will add with this force term, windage force term, and finally we'll get a very high torque. But that torque is not required. Uh, so what we have to do, we have to filter this data so that this high value of this traction effort is high value which is not required, is not is in our calculation. So now how do we filter this data? So the process is very simple. We will simply use a second order filter, butterweight filter, and the cutoff frequency of that filter is set to be is set for 0.4 hertz. So let me show you. So up to this point, if there is any problem or any question you want to ask, you may ask me.
Hello, sir.
Yes,
Yes.
sir.
Sir, are the spikes occurring due to temporal acceleration or what?
Uh, yes, this is this temporary acceleration because vehicle's speed, exact speed is not always constant. Our hands start means there may be some vibration in hands and the road conditions. Because of road conditions, also the speed goes on very, and very small fluctuations will always be there. They are not desired. And
Thank you, sir.
so now we have to filter this data, and this data means this is simply a velocity profile. The y-axis is velocity and x-axis is time, time in second. So per second data we will be using for this entire for this all calculations, and the speed will be in kilometer per hour, and finally we have to convert in meter per second because we will be doing all this attractive force calculation in MKS unit. So then we need everything in meter and second. So here this data is in kmph, kilometer per hour.
Hello.
So yes, sir. Hello.
Please continue, sir. No one is there.
Okay, okay, sir. And so we will be using a second order Butterworth filter and a low pass filter, and because we have to remove this high frequency noise, and for this what we will be using, I have made one. Uh, we made one MATLAB block in Simulink, and you may also use that block. And so, if this is visible to you, sir,
Yes, yes, visible.
okay. So this is one block that is from the workspace. You may select this block in the MATLAB just by going in this library browser, and many of them you might have used because this is a very simple or widely used or block. So here, while going in this library browser, you can click desktop. You will find these blocks from the desktop and sorry workspace. So you will find two blocks here, to the workspace and from the workspace. So these two, both these two are required here. We can drag them here, and the first one is the speed data, and this speed data we will be saving uh, at our workspace. So here we can save this speed data. Just one minute. It's not. And then the filtered. This is two workspace, and this is our output data, filtered data. And in between we use this block, and this is not a user made. This is MATLAB's own block, and if you may see the name of this block, variable bandwidth IIR, and in this block we can select this we want to use this filter as a low pass filter. So we use low pass, and order of this block, that is 2, second order passband frequency, that is the cutoff frequency, that is 1, and then ripple 1 dB, and then filter stop band attenuation, that is 60 dB. So, so after setting these parameters, we will run this block, and what we will get the filter data. So if you are working with a MATLAB version which does not support or which does not have this block, then we have another option, and what is that? You may just go here and just type here fit to block. If you may see this name, uh, fit to block. So what this command will do, it will generate a Simulink filter model as per our requirement. So, so filter to block. Okay, so fill to block, and what is this B and A? Uh, B is the cutoff frequency of the filter, and B is the order of the filter, and A is the cutoff frequency. So we will type this command directly there in the workspace, and it will generate a second order filter of the desired cutoff frequency. Just 1 minute. Write this command. Yeah. So what it will do, it will generate this type of filter block here, and these are the parameters of this filter block, and the similar thing we have done here. The same blocks. This is the input from workspace, that is raw data, and then this is the filter data to workspace, and this is the filter we uh, generated with this code with this, and here you can see in this filter, this is the transfer function of a filter, and for we know that for second order filter, this n is equal to 2. So now we have to, if it is 2, then we have to calculate it all these parameters b1, b2, b3 means and then a1, a2, and a3 is these coefficients. And here if we use this command to generate this to make this filter, then we need not to calculate all these coefficients. They are automatically calculated. So it will calculate these parameters. So these parameters are known. Here you can see this B0, B1, and B2, and then A0, A1, and A2. So, so we need not to calculate these parameters for that particular cutoff frequency and for that order and for that particular attenuation. So that is automatically calculated uh, if we use this command. And now what will happen, which type of data we will get after this filtering. So, so here you may see uh, two data. So this sheet shows the data we get from that app or that GPS app. So what do we get in that GPS app? The data, date and time, and then latitude, longitude, altitude, and bearing and speed, maximum speed, and all these data. So this is the one sheet which is generated with that GPS tracker code app. So that GPS tracker app, it generates this type of sheet of this complete for one cycle data is given here. And so this is the raw data without being filtered. And the second one is the filtered data. So you may see that there are many spikes in the raw data, and they have been removed with this filtering. So both these graphs are shown here for comparison. And now you may see that the maximum speed for both the filtered and raw data that remains same, and that is not being changed much. And maximum speed is same. And another thing, this area under the curve, uh, which we call, which we name the total distance covered. So that will also be the same for both these two data, so for these both two profiles, filtered and the raw profile. Because these very small spikes, they will not be changing the area too much. So the distance travel will be not affected. Maximum speed is also same. And but something which is highly affected, that is the acceleration. So here we have this acceleration uh, of both these data, and this is simply calculated from this velocity data. So delta v divided by delta t. So v2 minus v, or in discrete form, v2 minus v1 divided by t2 minus t1. Uh, so this is the acceleration. AR, which is the acceleration for the raw with the raw data, acceleration with the filtered data, and this profile is drawn here. These two accelerations are. So graph in this ACC, it shows the two accelerations, and we can see that it is highly affected, and there is a So unnecessarily, we were using this high acceleration data to increase the size of motor or the rating of the motor. So this data has been removed. And now what we have to do after this data. So once this data is filtered, what we have to do. So using this filter data, we have to cut into different uh, segments, and these segments are called snippets. If you see here, so we have to make different segments. We segmentize this of this raw data, this filtered data, into this different snippets. And one snippet, you may see that it has some particular average velocity and maximum velocity and minimum velocity and one time span. So how these snippets are formed and what are the different parameters uh, which we use to make these snippets. So here you may see that there are four parameters. Based on these four parameters, we will be making these different snippets, or we will be cutting these snippets from this filter data. And these are the A1, A2, delta, and N. And what is A1? A1 is the minimum acceleration of that particular snippet. A2 is the maximum acceleration in that snippet, and delta is the speed deviation, maximum speed deviation uh, during that snippet, and the n is the length, the time span, the length of this uh, time length of this snippet. So these are the four parameters we would be using while making these snippets, and means uh, for a particular snippet, a vehicle should have this much minimum acceleration, and a vehicle should have uh, this a vehicle should have A1 minimum acceleration, A2 maximum acceleration, and then the deviation in the speed of a vehicle that should not be more than delta in that particular snippet. And then the length of that particular snippet means, suppose if it is a completely very data speed data with a very small variation, then we cannot make the length of snippet as long as this data is constant. What we will do, that is the length of that snippet is limited also by this the time, so n, so number of time instants. So based on these four parameters, we will be cutting that raw filtered data into different snippets, and each snippet belongs to this particular set of these four parameters. And now so how to make these snippets with the filter data. uh, we would be writing here one VBA code for that, means for a snippet formation. So if you have Excel sheet, then please uh, open one Excel sheet. Are you able to listen me? Am I or
Ye- Yes, sir. Yes, sir.
audible? Okay.
Yes.
Sheet, and new Excel sheet as I do here, and name this Excel sheet and save this Excel sheet uh, as micro enabled workbook. Okay, so Excel SM. So because we need to write one VBA code, and that could be written only in this micro enabled Excel sheets. So save them as Excel this dot XLSM. Okay, so once you save this like this, here you can see in the name a new dot XLSM. So, and then what we will do, we will write one code for this snippet formation, and how we will do. So here in this sheet we have this filtered data in this column O and P. Column O is the time axis and P is the velocity in kilometer per hour. So we select these two. So in your case, you will not be having this data with you, this raw data. Okay, I will send this raw data after this session is over. So right now you may write this, start writing this code. So So now we have to write one code to segmentize this data. So what is the total length of this data here? You can see 935-second data we have now, and we have to make different snippets using that data. And how can we do that? So if you could save this sheet, then uh, you will find one macros here. So click on that macros. If you could find it. Hello, sir, am I audible?
Yes, sir. Yes, sir. You're audible.
Okay, sir. The pet is already there, so we name it. So you can name this macro and then create. So it will create one macro, uh, or we can tell this VBA, and here we will be writing our VBA code. So in this sub routine. So at first we have to write this. So now, to work on this data, what do we need? Uh, you may see that we have two arrays. In one array for time, and another array is speed data. So what we will do, we will take two arrays. So the name of these, we will take two arrays, and the name of these two arrays will be velocity data and acceleration data. Acceleration data, though it is not given here, we can calculate this acceleration data, and we can make another one. This is equal to. So if you know this acceleration data, then you can
Sir, I think your mic is muted, I think. Sir, we are not able to hear. Hello, sir. Rajendra, sir. Sir, we are not able to hear you, sir. Rajendra, sir, we are not able to hear you. Sir, we are not able to hear you, sir. Sir, we are not able to hear you. Not audible, sir. Okay. Okay, I think sir has got disconnected, so let's wait for some time. As we can see on his screen, he has written or disconnected.
Hello.
Yes, sir. Now it is audible.
Okay, sir. Sir, I'm sorry, it got disconnected.
Okay, yeah, yeah. So you can continue now.
Okay, so we were here. So we will take two arrays. one array is for velocity data, another array for acceleration data, and we will dimensionalize these two arrays in this VBA code. So dimensionalize DIMV data as double, DIMA data as double, and then we will use some integers. Uh, so, uh, am I audible, sir?
Yes, yes, sir. Yes, sir.
Okay, sir. Okay, so now we have taken these three integers, which we will be using for the loops, and then the time. So t denotes the time, and the maximum span is the n here. In this slide, we had four parameters. So n is the length of one particular snippet, maximum length of the snippet, and the same n is here. So we defined n as maximum span. T is the instantaneous time. Uh, Now for we'll take only this 100 data uh, just as an example. You may take this all 935 data and repeat the same procedure. So we have to redeem these two arrays with 100 elements. Uh, just now the number of elements in these arrays is not defined, and so we will define it here. So it shows that total number of elements in this V data array is 100. Similarly, we redimensionalize this acceleration data, just copy and paste and make this B V as A. Now we have to load these two arrays, velocity array and uh, acceleration array. And for that, what we will do, so where is that data? The data is in this sheet. Okay, so we have to fetch that data from this sheet uh, for this VBA. So how we will fetch? Simply we will use one for loop, and So from int k is equal to 1 to 100, what we have to do? We have to load these two arrays. So where is that data? So that data is in worksheets. So in which worksheet this data is? So the name of worksheet is sheet 1. So we will write here cells, and so acceleration data it starts from the second cell, second row, and it is in this third column. So it starts from second. So second means first plus int k comma 3. And similarly, we just copy this thing, paste here v data, and v data is in second column, and then we end this loop, starting next. So now this data is loaded, and now what we have to do? We have to make snippets. So for snippet formation, we have four parameters. So right now I am using only these two parameters, a1 and n, and you may try with these all the four parameters. So a1 means the acceleration, maximum acceleration, and n is the length. Okay, so now what we will do, how we will make snippets. Uh, we will monitor this data for this entire length of this drive cycle. Uh, from the length we have selected, we have taken 100 seconds data. So for all these 100 seconds data, from t is equal to 1 to t is equal to 100, what we will do, we will monitoring this data, and the moment the acceleration uh, value increases from the specified acceleration value, or which was the uh, A1, or uh, the the moment when the time span it crosses this maximum time span, at that time we will break that chain of data. So this is what we are going to do here. So we will use this uh, if statement here. So as of now, we have taken these two parameters, A1 and N. So if acceleration is greater than A1 or the length of the chain is greater than N, so at that time we have to break this data chain, and that particular segment between these two consecutive breaks, that will be our one snippet. So so here this maximum acceleration we have set 1. So if the acceleration is greater than 1, or if the or sorry and the time span is greater than this maximum time span, at that time uh, we will break this chain and take that data one as one snippet. So as long as this condition is met, means acceleration is less than 1 and time is not equal to the maximum time length. So till then, what we have to do, we have to give some one increment, and the moment this condition breaks, we have to come out of this loop. Sir, am I audible?
Yes, sir. Yes, sir.
Okay. This condition is met. Okay, so this is one routine we have written here to make these snippets, and now we will run this uh, routine. And before that, we have to make one sheet here, sheet 2, because we have mentioned here about this sheet 2. So now if we run this code, what will it will do is it will make different snippets of the data, and take the it will fetch the value from sheet 1, and the snippets will be generated in the sheet 2. So everywhere you have to write worksheets. This code is run, and now we check this data. Okay, 1 minute. Just 1 minute. We have to close all these other uh, sheets. Okay, let me close all these sheets and open it again, because multiple sheets are opened, and Hello, sir. Am I audible?
Yes, sir. Yes, you're audible.
Okay. So now, if we run this code here, what we will get all these snippets data here. So in this sheet, so we can draw all these snippets. This is first one, and second snippet. So this is how we have made. So how many snippets are there? So this is S1, and S9 we can take. This is only single entry, so we can cut and paste it here. So we have total 9 snippets here, and if we join all these 9 snippets, writing them, if we connect all these snippets in a sequential manner, it will be this drive cycle data. And if they are segregated based on the time instant n, and if they are segregated based on this acceleration, then it is not necessarily to be the same drive cycle or the same filter data chain. So, so please tell me if you have any doubt up to this point.
Yeah, participants, if you have any doubts, you may ask.
Okay, sir. Then uh, may I continue now?
Yes, sir. Yes, sir. Please.
Okay. So now, what after making these snippets, what we will do? So here you can see these two datas, velocity and acceleration data, and now these two data will plot on a single plane. Single plane means x-axis is the velocity and y-axis is acceleration, or vice versa. So we take these two data. So just selected these two and insert, and after going to the insert, we come here. So now you may see this type of plot in the Excel. So you can change this color of these bubbles. Okay, so what I mean to say, this is the same data in this graph, this acceleration versus speed graph. And now after making this snippet, what we have to do, uh, we have to make different states. So different states means as shown in this sheet here, in this picture. Uh, so here y-axis is the acceleration and x-axis is the velocity. So there are different states, and each states represents a particular range of acceleration and a particular range of velocity. So if our vehicle is in this, its velocity is in this range, acceleration is in this range, then it belongs to this state one. So similarly, we have to take only this positive acceleration data. Negative acceleration data is not required because we will be using only this mechanical brake for during this negative acceleration. So we will take only these positive states, positive acceleration states. So for this data, what we had this acceleration from -2 to +2, and so we will make different states. We will segregate this data, classify this entire these all these snippets again based on their these velocity and acceleration values, means to what state they belong to. So and then with using these states, we have to make one transition probability matrix. So what is that transition probability matrix? Uh, it shows the probability of a vehicle uh, from moving one state to another state. So, so in this sheet, suppose our vehicle is in state m+2. So at any instant t. So at any time instant t, vehicle is in state m+2. Then what is the probability of the next time instant? Our either vehicle can slow down or it speeds up. There are two possibilities. So in the next instant, whether this vehicle will be in the state m+3 or will it be in state m+1 or any other state. So that probability that probability is represented by this TPM, transition probability transition matrix. So this TPM. So here, suppose we have the P22. P22 means sorry, P12. So P12, what does it reflect? That vehicle is in state one at particular instant, and P12 is the probability of that vehicle for being in state two uh, in the next time instant. So this thing is represented by this transition probability matrix, which is known as TPM. So these all entries are the probabilities, and if it's P11 or P22 or PNN, sorry, PSS, they are the probabilities, means vehicle will not change its state in the next instant of time, and all other entries they belongs to the vehicle's next state transition. So if we go for a particular row, if we go from P11 to P12, so what do we observe here? That these probability values, they goes on to decrease. Okay, so if we move from right to left or left to right, suppose PSJ or the, so why it is going to decrease means it is not expected that the vehicle is in a particular very at zero speed, zero acceleration, and in the next moment it will be in uh, its speed will be very high, or its acceleration uh, or speed will be very high. So that is not possible. So that's why these probability metrics they have very large values which are zeros. So it is an means a sparse matrix. So so most of the entries will be zero only, and diagonal and the values nearby this diagonal elements they will have some certain values. And one more thing, that sum of all these entries along a particular row, that should be one, because vehicle has to be somewhere in the next instant of time. So the sum of these entries equal to 1. Okay, so please tell me if you want to ask me anything.
Yes, if anyone is you may discuss.
Hello, sir, I'm audible.
Yes, sir, you're audible.
Okay.
Uh,
So, okay, sir. So, if there is no query, then rest of the things we can leave for tomorrow's session.
okay, sir. I think yeah, it's already 4:30, and yeah, rest of the things we can continue, and tomorrow in the second half again, we can continue
Oh,
with the stuff. Yeah.
okay, sir.
So thank
Okay.
you very much, Rajendra sir, and
Thank you, sir.
we'll see.
Thank you to give me this opportunity
Yeah,
to
yeah.
interact with you, with all
Thank
of
you.
you. And
Yeah, it's a
yes,
privilege.
thank
Yeah.
you.
So
Thank you
tomorrow
very
again,
much.
we will see. Yep.
Yes. Yeah.
Yeah. So, dear participants, thank you very much. This is the end of today's session, and tomorrow we will start with the uh, basic modeling on dynamics of electric vehicles, and which will be uh, delivered by Professor Amit Kumar Jain from IIT Delhi. And the second session will also be continuing with the same person. And the last session will be having Rajendra sir again with us. And so this is all for today. So thank you for being here. So thank you so much, everyone.
Thank you.
Thank you, sir.
Thank you, sir.